Okay, I've got 9 o'clock. Out of respect for everybody's time, I'm going to go ahead and start today's class. This session is being recorded, and it will be placed in the recorded presentation section of your MyTCC class link by later on today. Today on the schedule, we have covering Chapter 2 material. And like I talked about last time, from now on, because last week we had a vacation on Monday, from now on, we will always on Mondays, we will cover a chapter, a material or chapter or two of material. And then Wednesdays will be the day if you want to come for the in-person lab experience. You can come on that day at 9 o'clock. Or of course, you can choose to do that remotely if you want to do that as well. Okay, before I start onto the Chapter 2 material, I want to go back to Chapter 1 for just a second and review this concept of our basic troubleshooting test, which was ping and trace route. So hang loose, I'm going to share that screen. And someone has joined one in a second. I'm going to add them to the roll. Now, when you use your command prompt from Windows, it looks slightly different. I'm running this session from a Macintosh, so the Macintosh doesn't use the Windows operating system. Maybe you're running the Linux operating system. There's several different operating systems that are available out there. So they talk in the lab that if you're in the Windows operating system, you would type this particular spelling of trace route, which is kind of abbreviated to the trace command. Or if you're on a Linux machine or a Cisco router or a switch or a Unix machine or a Mac OS machine, which is basically a Unix machine, you would type it slightly different. The thing is spelled the same. So this concept was, we had a slide last week that talked about we use ping to test whether we have full end-to-end connectivity between two devices. So here I'm at home with my AT&T home router, and I should be able to ping, the MyTCC site. And this response indicates I've got a successful connection, a full end-to-end network connectivity between here and the TCC Blackboard site, my.tccd.edu. Okay, how about that? Ping the Network Academy site, where you get your free ebook and where you take your tests. Oh, bad magic. What's going on here? Oh dear, can I not connect to it? So here's a gotcha about this ping and trace route thing. Bad guys, black hat guys, in the Westerns, you always know who the bad guys are. They always wearing a black hat. You always know who the good guys are. They're always wearing a white hat. So in network security, we use similar terms. Us white hat guys, we're the good guys. We're promoting security, network security education and awareness among our users and our network technicians and engineers. And the black hat guys, these are the guys that are trying to break into our network. Now, the first step, if a malicious intruder, the question is raised by, is attendance graded? And attendance is not graded, and it's not required in the sense that it used to be, where if you missed 15% of your classes, you could conceivably be dropped by the dean or something like that. So not required. You can watch it later in the recorded presentations. The only thing you're going to be actually graded on this class is 50 points for the midterm and written exam and the final written exam that's on netacad.com, and these 7 labs that we do. So in networking security, the black hat guys, the guys that are trying, well, we used to call them hackers. I don't like that term. The word hacker used to be a term of honor. It was a person who could write such elegant code that old timers would go away shaking their heads in disbelief that this young upstart youngster could write such great code that did a great job. But you have been conditioned by the press. Whenever you hear the word hacker, it's kind of like when you hear the term conspiracy theorist. You think that's a bad person and you shouldn't pay attention to what they say, or you will need to watch out for them because they're trying to hack into your system. So for a while we called them malicious intruders. bad guys. And I think the correct term to use now is a threat actor. So if you go through the Cisco, get the Cisco CCNA, and then you go back and work on, say, Cisco cybersecurity operations, which is a great thing for your career to learn a little bit about security. They call them threat actors. Now that's the people they're the black hats. They're trying to break into your system. So for this reason, this ping and trace route that we're fixing to briefly cover here for just a second from last week, this is a tool that bad guys used to try to map out if you're their target and they're trying to do the ransomware on you or something. They're going to try to figure out what all devices do you have. I'm going to try to ping every particular network address, IP address you have and figure out which ones are Microsoft servers. Those are pretty easy to break into. Or Linux servers. Those are a little tougher to break into. So the first thing they try to do is ping and trace route everything at your company. So for this reason, some companies filter this out. So when I tried to ping networkacademy.com, well, that's Cisco. Cisco's a company that knows a little bit about security. So they're going to allow that ping to go in there and try to map out what devices they have so they can come in and break into those. Okay, let me ping something that almost always works. That's the, oops. Yahoo, the web search engine, and the the Yahoo email that you can get for free. That works just fine. So some companies just have a policy that they're gonna filter this stuff out. They're gonna map it out where you can't use it. So when you use this traceroute utility, oftentimes you'll run into a situation where ping gives you is a utility, test utility that gives you end-to-end connectivity. So it's like sending a sonar pulse from the submarine to the battleship, and he's verifying the range to the battleship so you can blow it up. Traceroute gives you a step-by-step report of all the individual routers that are between you and that device. There's an average of 10 or 15 routers between you and whatever website you go to. So some of these internet service providers or companies may filter this out, and it makes it more difficult for the bad guys to figure out what's going on. The good guys that are the authorized people that are actually working on these devices, they know what addresses they are, and they can work on them. So let me do a trace route. Now, if you were on a Windows machine, you would tap at trace RT. But on this Macintosh machine, it comes back on the error because that's not the way he spells it. So I'm going to type trace route yahoo.com. And this is showing us all of the internet service providers, the backbone of the internet guys that are in between me and the Yahoo website. And so my home router, that's that line number 1, 192.168.122.54. That's my home router's address. The next one, number 2, that's SBC Global, Southwestern Bell's, what it used to be called. Now they're called AT&T, but they didn't change that name. And so you see all these links in there. So it looks like there were 16 routers between me and the Yahoo website. And all these little different ones that are in between here, all these numbers between 2 and 15, these are the other routers that connect everything together. So router's job is to choose the best path and get your packet delivered from one device to another device very rapidly. Now I'm going to let's try that Network Academy again. So it went out from my number 1 is me here at home. The Lightspeed.Fort Worth, Texas is my AT&T. That's who I get my internet service from. Most of you guys would see the cable company. In my experience in my classes, most people use the cable system instead of the telephone company system. So we're getting some dots here, some asterisk, asterisk, asterisk. Who is that number 6? We can't tell. If you were a bad guy, that would deny you the knowledge of what ISP or what company that information is flowing through, and you wouldn't be able to break into them. So sometimes when you do these trace routes, you'll see this continuing series of asterisks and going real slow. That means that you're getting into a portion where maybe we're at the internet service provider that Cisco uses, or we're within the Cisco company, and they're just not going to let us see that stuff because they don't want hackers to try to break in there. I'm gonna stop that. So that's the deal with ping and trace route. Ping gives you end-to-end, either it works or it doesn't as a whole. You can connect or you can't connect. But if you're a network technician or engineer, it's often useful to figure out, well, where is the disconnect? There's 15 routers between me and him. Which one did it occur at? And so the traceroute command can give you more information. You know, it went to this router R1, then it went to this router R2, then it went to this router R3, and it never met at R4 because you didn't properly configure the two routers or something of that nature. Okay, that was very highly technical, and this is even fundamentals of fundamentals class. So sorry for the confusion there if it created that. I'm going to stop showing this now. And I'm going to start sharing Death by PowerPoint. So chapter 2, networks and our daily lives in this Network Essentials course. So we're going to look at basic requirements for getting online, look at how we represent networks, and cabling and media. How do we tie all this stuff together? So getting online. So most people have smartphones these days. Oh, I'm a real old timer. I've got one of these flip phones. Yeah, they turned the flip phones off. They were 3G. I use the old guys telephone company network, consumer or cellular, and they turned off the 3G, and so we had to go get a smartphone now because they're 4G or 5G. So mobile phones, when you're using them to connect to the internet, to your Facebook or whatever, the media, which is the way that the bits travel to and from your device, is radio waves. So they transmit the radio waves, represent eventually what are bits, whether it's internet data or your voice. It's all turned into a series of ones and zeros bits, and they're transmitted to there's a local tower within a few miles of where you're located, everywhere in the country. Well, not in the middle of the Gobi Desert, but most everywhere else. And so generally speaking, you can have good internet connectivity. So the 3G, 4G, now 5G stuff is the newer technology that they're using. Other networks, the global positioning system. These are the satellites that you use when you use MapQuest, or what's the one that everyone's using now that tells you where the traffic is, that will tell you, map out your route when you want to go to someplace. If you're at home and you have an internet service provider, you probably have a Wi-Fi access point built into there. And you can use this Wi-Fi access point to connect to the network, save on your cellular minutes. Bluetooth is another particular option that's available to be used there. Okay, oh dear, this is so highly technical. Well, at least we're not doing subnetting. We'll get that in the next 8 weeks. So what are examples of things that perform a network? We talked last time about end devices and intermediate devices. An end device is something like your desktop PC or your phone or your laptop computer or a tablet or a printer or something, maybe a server in a data center, something that either starts the flow of network data flowing or responds to a request from a user and gives the answer back. So examples of end devices like PCs, servers, and intermediate devices. These are devices. Your home router is an intermediate device. It connects your home network to, you probably got the cable company. I've got the telephone company. So intermediate devices, routers, switches, things of that nature, connect things together. They don't start the flow of data themselves. They merely relay the request you made from your client desktop PC to that server in a data center, and then the service sends the answer back to you. And all these switches and relays choose the best path to send the data back and forth. So we have intermediate devices, we have end devices. The new buzzword for end devices is endpoint. That's the new Cisco buzzword for that. I've got an endpoint. Oh, they're so cool. And then we have the devices that plug everything together. The cabling of the media is the correct term for this. So the media could be twisted pair Ethernet cables, those blue cables you see everywhere. Could be Wi-Fi, could be fiber optic cable. So at home, you probably have a combination of network cabling, wiring, real physical wires that transmit electricity with the bits of electricity represent ones and zeros, and Wi-Fi. Maybe you're lucky enough to be in a neighborhood where they've pushed fiber into the ground and you have a fiber optic high-speed gigabit connection to the internet. So in commercial industrial applications, like at the school, we have fiber optic cable that connects all our buildings together because it's due to the nature of the way the electricity travels through copper cable, it sort of weakens or it sort of fades out as it goes through more than about 300 feet of cabling. So it's more, it makes more sense to use a fiber optic cable between buildings where the buildings are more than 300 feet apart. So all our buildings at the South Campus are tied together through fiber optic cable that's buried in the ground. Everything is buried in the ground. You notice there's no phone poles. We have a system of tunnels that connects all the campuses together, and that carries all the, the hot and cold water and the heating and the cooling and the telephones and the electricity and all the data cabling goes through that. So these are three things that are used to send, either fiber optic cabling or twisted pair copper cabling or radio waves. Now let's look at our end stations, our endpoints. So there is three basic numbers that need to be assigned to every device on the network so that he can communicate with the other devices on the network. And this is very similar in theory to, we have to assign a telephone number to your cell phone. So if you want to change if you change carriers, or you want to change your phone number because you're getting a bunch of bothersome telephone calls, they can change your phone number. They don't have to change your hardware. They don't have to go get a phone. They'll just change the program and it'll change your number. So you've got an area code, and then you've got the 7-digit number that corresponds to whatever carrier you're going with. So with computers, it's the same sort of a thing. We need to assign a unique IP address. That's an individual unique address that identifies, when he uses the word host, that's a technical term. It just means something that plugs into the network, like your desktop PC or a server at a data center. That identifies your host. And it's kind of like a telephone number. The first part of the numbers indicate what company or what region it belongs to. And the last part of the numbers indicate, well, which particular computer at that location is it. The second number is something called the subnet mask. I don't like the word mask. It sounds like Phantom of the Opera. It sounds like they're trying to hide something from us. It's spooky and scary. Actually, I would rather it be called the subnet yardstick or the subnet ruler. The subnet mask is the thing that tells us, on that IP address that we just looked at, how many numbers is, think of the telephones, how many numbers are the area code and how many numbers are your telephone number? Well, in the United States of America, the first 3 numbers is the area code, and the last 7 numbers is your individual telephone number within that area code. Other parts of the world, they don't have 300 million people in their country. They've got a different number of digits for their telephone numbers. So networks are the same way. Some networks are big and some networks are small. Well, Tarrant County College has got 4,000 employees and 100,000 students. We've got a fairly big network. So the subnet mask is used to tell all the devices, how big is the network that I'm plugged into? I have routers that connect them to all the other networks. I can connect to them. I can send packets to them and receive the answers back from them. So every network has been configured by some network technician or engineer to be a certain size. A normal size that's very common is around 250 devices are on this particular individual network. So that's the second number that we identify when we configure a device. The third thing is, what is my way of getting out of this network to get to all the other networks? Routers connect networks together. Routers used to be called gateways. So the old terminology is still used. The default gateway is used to identify, I call it your friendly neighborhood router. If you want to talk to someone else, then we're not in the classroom, we have a direct connection to each other, I have to have that relayed by my friendly neighborhood router to all the other routers in the world. And they have routing tables, they know how to connect everybody else, and they'll connect that for us. Now, there's 2 ways of configuring these 3 very important numbers. We can do it manually, and that is such a drag. It's such a drag that about 1995, they came up with a protocol of automatically assigning all these, which are basically binary numbers, 32-bit binary numbers, like 192.168.1.1, to all these devices, so that us network administrators didn't have to run around and assign them by hand. I used to have to do this. So in the 90s, I worked downtown Fort Worth at a big publishing company, Harcourt Brace College Publishers. We had about 200 people there in the building, had about 200 salespeople that worked out of their homes throughout the country that would call on colleges and try to get them to adopt our textbook titles. And I would have to manually configure all these devices. And if you move from one floor to another floor, you needed a new network address. And I had Excel spreadsheets that kept track of which numbers had been used and which numbers were no longer being used. And it's very difficult to manually configure these. So in about 1995, they came up with a special network protocol that would automatically assign network addresses to every device, so that if you, for example, say you bring your laptop computer and you come to my laboratory building, the SBS 1125 on Wednesday, and you get a network address from your Wi-Fi. And then you go to another building and you're on a different network, you'll automatically get the new proper numeric value for that building when you go to that building for you. This automatic configuration protocol, technically it's called Dynamic Host Configuration Protocol. It's a thing that assigns IP addresses to all these. So this is used universally now because network administrators don't want to waste time having to do this job of configuring numbers, which we used to have to do all the time. Your home router does this. Your home router has got a little built-in DHCP server that anytime you plug anything into your home router or you attach with a Wi-Fi, it will automatically assign addresses. So you don't have to go into the network control panel of your Windows and manually assign an IP address. Now, when we do labs in the Cisco Network Academy, we start by doing some manual stuff. So when you did that lab on packet tracer, you had to assign the 192.168.1.10 and the 255.255.255.0 to those two devices. And I think the second one was 192.168.1.11, and you were able to ping back and forth between those. So, in karate, they say you got to do your 10,000 falls. Well, in networking, you got to do your 10,000 configs, and then you get to be pretty good at it. So IP addresses can be configured manually. Normally, we do this when we teach a lot, but normally in the real world, we let computers love to keep lists of numbers, so they'll do that for us. Okay, some other network considerations. He says when a network grows, we want it to be scalable, where we can grow without having to throw everything out and start all over again. We should plan these things out and use some logical type of organization, and most importantly, document it, write it down. So some networks sort of grow piece by piece, and no one ever really wrote it down. And different people built different parts of it, and they left the company, and no one really has an idea of what's going on with the network. And when something breaks, that's a problem because we don't know what's connected and what each thing is doing. So when we install networks, we're going to create a physical topology. Where is each host machine located? What room is it located on the blueprints? How is it connected to the network? So this shows how the wiring is installed, the locations of the devices that connect the hosts. If you come to the computer classroom on Wednesday, you'll notice that all the network jacks, the RJ45 jacks that connect everything together, have got a number on them, a unique serial number. So our physical plant people, in most companies, we call it the facilities management people that install and maintain the wiring. They know where every wire starts and where every wire ends. If you don't know where the wire goes, how are you going to fix that? Here are some of the icons or graphical representations of different devices, like for desktop PCs, laptops, and things of that nature. So in devices, they start or you print something to the printer. Your desktop computer started the flow of data. The printer received the flow of data. He printed out the paper for you. Intermediate devices are the things that connect all of the devices together and choose the best path. So like a home router, a Wi-Fi type router, local area network, Ethernet switch, routers, firewall devices that protect. The firewall devices are the things that protected me from being able to run that traceroute command and seeing all those values. They had configured their firewall to hide this stuff because they didn't want the hackers to be able to go in there and use that stuff. So when we connect these devices together, we're going to use network media. Now that little blue sine wave looking thing, that represents radio waves, like Wi-Fi. The dark black line is our traditional representation for twisted pair copper cabling, or maybe fiber optic cable. The jagged red lightning bolt thing is what we use to connect from one point to another point, say from a home office to a branch office. That red jagged lightning bolt thing would be used to represent the connection from your home router to your cable company, or in my case, from my home router to the telephone company. So I think I talked about LAN and WAN last time. Local area network is a network that's within your house. Geographically in one very small location, permanent 100% high-speed connectivity, and owned by you. You get to decide what to do with it. Tarrant County College owns lots of networks. We get to own, our chief network engineer gets to decide what we're going to use. Wide area networks are networks that we have to typically lease from somebody else to connect our branch offices together. You have to pay the cable company a certain monthly fee, a recurring fee, and they'll give you a connection to their system, which connects to the internet. So logically, we had physical topology, which is like the blueprint that showed where everything was located. And then the logical topology is, well, logically, what IP address am I assigned to the server? What IP address am I assigned to these classrooms? It doesn't really have any representation to the real physical blueprint, but it's something that we use in networking because we need to know. We don't really care where it's located, but we need to know. We need to be able to configure it so that we can make the whole network work properly. So the same icons are used both if it's a physical and a logical. And as we go through the Cisco Network Academy stuff, we're going to mostly use these logical topologies. Okay, cabling and mean, I talked a little bit about that already, but let's look at this. So copper, fiber optic, and wireless, they show in the graphic diagram. So copper cabling it's usually blue or yellow, but you can get it in pretty much any color you want to. These are the twisted pair cables that carry the electrical impulses that represent the bits, the ones and the zeros. In binary computers, everything's bit level. It's either 1 or a 0. So there's one type of electricity, that's a 1. And there's another type of electricity, that's a 0. And we just shoot the proper type of electricity into these copper circuits, and they carry the bits from your device to whatever you're plugged into, probably like an Ethernet switch, or in your case, the Ethernet switch is built into your home router when you're at home. So copper wires within cables, and they use insulation around the cables. It's not high current, high voltage, can't shock you. You can't even feel it, but it's insulated so that it doesn't short out and not work properly. Fiber optic cables don't use electricity. They use fibers in which we can send little pulses of light. And instead of using electricity to represent our 1s and 0s, we're going to use pulses of light to represent our 1s and 0s. They usually can go much faster than copper cabling. And another big advantage of fiber optic cable is it can go much further distances without having to be gussied up and repeated again. So with twisted pair cable, copper cabling, we can only go about 328 feet. With fiber optic cable, we can go much further than that. So on the campus, the problem is fiber optic cable are more expensive. They're harder to put the connectors on and so forth. So in business and commercial use, we typically use twisted pair copper cabling because of its lower expense and ease of use to connect all our devices together to a wiring closet. And then maybe from the wiring closet from that South Campus business building to the library, we would use a piece of fiber optic cable there because it's more than 328 feet. It can go longer distances. Now, one of the problems with twisted pair cabling and electricity is it's sensitive to interference from outside world things. So here at the South Campus, across the street, we've got this big radio tower. That's the Public Service, County, Fire, and Police Department communications, radio communications. That generates a lot of radio frequency interference, RFI. Another source of interference can be anything that a large amount of electricity flows through. For example, a fluorescent lighting fixture in an office building is 277 volts, and it emits a lot of electric interference in the vicinity of that lighting fixture. So when I worked downtown at Harcourt, I had my data center right across on the other side of the wall was the elevator motors for the entire building. That was a source of electrical interference. Another type of interference that can occur is when you take a bunch of cables that are bundled together. A cable from one cable can, electrical signal from one cable can sort of leak into the adjacent cable and create some interference in that. So what we do with with the twisted copper cables is we twist them together tightly and that tends to sort of reject outside interference. But in the diagram here, in the graphic, you can see that if we have our pure digital signal, which represents ones and zeros, and then on the right at the top, we have some interfering signal. If that interfering signal adds to the intended signal, and we get that interference, it changed one of the bits. There was a bit that was supposed to be a 0, and that electrical interference made it a 1. Oh, so now we have corrupted data. So this means that not only do we have to transmit the bits representing our data from one point to another, we have to be able to detect if an error has changed the signal and know that we need to be able to retransmit that data again and try to get it back the next time. You are probably using coaxial cable from the cable company to attach to your set-top TV box, and maybe you have a cable modem that comes into your house to connect to that. So coaxial cable used to be the only way that we would connect computers together in a network. And that was back, the Ethernet scheme was invented back in the late 70s. And it was originally used coaxial cable. And then finally the phone company guys talked to these networking guys and says, you guys are nuts. What are you using this coaxial cable for? It's thick, it's difficult to work with, it's bulky. Why don't you use twisted pair cable? And the networking guys listened. So by about 1990, it was very unusual to see any more coax cable anymore. And all the networking adapters had changed over to this twisted pair RJ45 connector. So if you went and bought a network adapter to plug into your PC in 1990, it probably had 3 connectors on the back of it. It had an RJ45 connector in case you're using twisted pair cable. It probably had the big, thick twist-on, like this twist-on connector we see, the BNC connector, had a connector for that. And it probably had a big, looked like a game port connector if you had this super thick cable. So if you bought the NIC card, the network interface adapter card that you bought to plug into your PC was probably $120. Well, go to Fry's today and buy a network adapter for your PC. It's probably going to be $7. It's not going to have these other 2 connectors. It's just going to have the RJ45 connector. Hold on, hang with 1 second. I'm just checking for new attendees. I think I've got everybody here. I'm with you. Hold on. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing somebody. Hold on. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I've got you. I've got you. Okay. Okay, so if we didn't have this high technology fiber optic cable, I started working at the South Campus in 1981, and we used to have coaxial cables that went through all our channel systems to connect everything together. Back in the days of IBM mainframes and dumb green screen terminals. We don't use that anymore. We use fiber optic cables now. The twisted pair distance limitation I spoke about 328 feet. Well, coaxial cable is thicker and has better shielding on it, so you could go quite a bit farther than that, maybe 4 or 5 times further than that. Now, we could make it from the library to the business building, but it was subject to all the problems that electrical cables like crosstalk interference, radio frequency interference, electromagnetic interference. So fiber optic cable doesn't use electricity. It uses pulses of glass. It's totally immune to ground fault currents, radio frequency interference, electromagnetic interference, and plus it can carry the data at such a higher rate of speed and such further distances. It's what we use today. If we want to go more than within a single building, we're going to use twisted pair copper cable, but when we go anywhere else in our facility, we're going to use fiber optic cable for that. Now, oh, this is kind of technical. The phone companies have had a standard, a color coding standard for their telephone wires for over 100 years now. And when computer networking, data networking started becoming more popular back in the 70s and 80s, when Ethernet started becoming popular and people started to network all their computers together, particularly in business, commercial environments, There's a trade organization called the Electronic Industry Association, Telecommunication Industry Association, EIATIA, that set some standards so that if someone wired one building and another contractor wired another building, everybody's equipment would work with it. So in computer networking, we've sort of settled on this, what we call an RJ45. It's an 8-pin connector. It's kind of like a telephone plug on steroids. Telephone plugs only have 4 or 6 pins. But Ethernet cables, any type of networking cable uses this standard RJ45 connector. And there's 2 possible color codings that you can use when you punch the pins down to these connectors. Doesn't matter which one you use, just as long as you're consistent. So one company may use the A standard. One company may use the B standard. If you swap them, they'll be crossed with each other and you might have problems. Okay, we'll get into this in the next class after the spring break. We call them straight through cables, crossover cables, and console cables, but we'll worry about that later. Okay, I think I've covered everything I need to cover for today. So wait a minute, so I need to chat here. What's going on? Oh, so Benjamin pointed out T568D. If you want to wire your house or wire a company, you'd have to buy either all 568A jack patch panels or 568B patch panels. So this could be a problem. I'll tell you a story and I'll let you guys go. When I was working at Harcourt, we had a company come in and wire the place. And so this is back in the early 90s. It was old category 3 cable, which is still obsolete now. And so this is the big building downtown that's across the street near the courthouse, the 2 twin black towers that we have in downtown Fort Worth. They're about 40 stories apiece. And then we had about 80,000 square feet in the building. We had about 5 floors that we had. And so the company came in and did all the wiring, and they put the RJ45 connectors in each individual cubicle and office, and almost all of them worked fine, except in every corner office. Now, who goes in the corner offices? The big wigs, the most important people who are the most prone to complain the most, okay? So in each one of these, there's only 4 corner offices in each floor, and we only had 5 floors. So only the 20 biggest big wigs with the most political power in the pool in the company could get those corner offices. And these typically tend to be the people that don't understand computers and like to complain the most. So in each one of these corner offices, there was a pillar, which was round, it wasn't flat. And when the installers had come in and put in the wiring, they put in a particular plug there. It looked like an RJ45. You could plug a RJ45 plug into it, but it was a special type. I think it was called an RJ48 or something like that. Had a key connector in it. The color coding was not the proper color coding for TIA, EIA 568A or B. And so none of the PCs in those offices worked. And my first job there was getting everybody plugged in and get them connected. So I finally figured out what was the problem was I had a little $200 device you could plug in, and it would show you the wire mapping that showed what colors plug. What pin does pin 1 of this side go to pin 1 the other side? Normally pin 1 goes to pin 1, pin 2 goes to pin 2. So when I checked these corner offices, and only these corner offices, there was no proper pin mapping. Turned out it was a connector, it was a DECnet connector for the digital equipment mainframe stuff. So I was able to prove to the installers what the problem was, because of course they would say, well, that's not our fault. Your hub is bad. I was able to show them the wire map and show the problem was, and they were able to come out then and remap them properly. So we could do that. And the most important people in the corner offices then were plugged in together. So that was my first big success there. I got them all happy. The question has been posed, do we need to use microphones or cameras for the online lectures? So here's the deal, which we've learned in endless faculty meetings. If you want to hear people complain, go to a faculty meeting. These people complain about everything. Have your microphones cut off, because I can't tell you how many faculty meetings we've gone to where we heard barking dogs and crying babies. Yeah, so your microphones are disabled. You can turn on your camera if you want to. I'd love to see you. The cameras, you can turn on your cameras if you want to. You don't have to. As a matter of fact, in all the lectures I've done since spring, I've only had 1 or 2 people that dared to show their faces. But if you want to turn on your camera and let everybody else see you and see what you look like, that'd be fine. You can do that. Sorry, microphones have to be disabled. So if you have a question, just chat, type in the chat, and I can answer you vocally. Okay, so let's see. Hang loose 1 second. I'm going to stop sharing this. We're going to go back to this. Share the application. So we have covered Chapter 2. I gave you a little review about ping and traceroute on Chapter 1. All our future lectures will always be on Mondays till we come to the end of the semester and final exam week. So our first in-person lab opportunity will occur Wednesday at 9 a.m. And you can come in person or you can do it remotely. So normally you would use the packet tracer software. On this particular lab that we're doing on Wednesday, the Sign Lab on Wednesday, it doesn't use packet tracer. It uses you need a computer with network connectivity like your own computer. You probably run in Microsoft Windows, so you use the command prompt or the DOS prompt to do that stuff. Okay, that's a one for the books. I'm going to stop now. Hold it. I'm going to stop recording.